Hello everyone. Welcome to the Building Services Subject Lecture. Myself Vinod Shivkumar. Working as an assistant professor in the Department of Civil Engineering at KPR Institute of Engineering and Technology Coimbatore. Unit 4, Fire Protection, Acoustics, and Sound Insulation. We will explore the following topics. Introduction, Causes of Fire and Effects of Fire, General Requirements of Fire-Resisting Building as per ISN NBC 2016, Characteristics of Fire-Resisting Materials, Maximum Travel Distance, Firefighting Installations for Horizontal Exits, Roof Exits/Fire Lifts, External Stairs, Requirement of Good Acoustics, Various Sound Absolvent, Factors to be followed for noise control in residential building. Introduction. It is the objective for every engineer while planning and designing building structures offer sufficient resistance against fire. All the structural elements such as floors, walls, beams, columns should be made of fire-resisting material. Adequate means of escape are provided for occupants to leave building quickly and safely in terms of fire breakout. Following types are nature of hazards associated with fire. Personal, hazard to occupant of building. Damage, hazard to structure and content. Exposure, hazard to spread of fire to other building. Code books to refer. General requirements of fire-resisting building as per ISN NBC 2016, National Building Code Part 4, Fire Safety, page No. 22. Travel distance, the distance to be traveled from any point in a building to a protected exit or external escape route or final exit measured along the line of travel. NBC Volume 2, page No. 32 Table 5. Firefighting installations for horizontal exits, roof exits/fire lifts, external stairs, National Building Code Part 4, Fire Safety, page No. 30, 31. Common causes of fire and consequences. Common causes are faulty electrics, flammable or combustible materials, human error, negligence, arson. Consequences: death, personal injury, building damage, flora and fauna damage, loss of the business and the jobs, transport disruption. Requirements of fire-resistant buildings. Using suitable materials. Taking precautions in building construction. Dimensions of building components. Compartmentation. Fire protection materials. Exit requirements as per NBC of India, which involves provision of sufficient exits to every building to permit safe escape in the case of fire. Exits should be free of obstruction, and provision of adequate illumination, lighting. Provision of fire alarm systems and fire extinguishers. Properties of fire-resistant materials. It should not disintegrate under the effect of heat. It should not expand under heat so as to introduce unnecessary stresses in the building. The material should not catch fire easily. It should not lose its strength when subjected to fire. Fire protection. In fire protection, maximum travel distance refers to the maximum distance a person must travel horizontally to reach a fire exit, such as a stairway or an exit door, from any point within a building. This distance is regulated by building codes and standards and depends on factors such as the occupancy type, building height, and fire safety measures in place. The goal is to ensure that occupants can evacuate a building safely and quickly in case of a fire. Fire resistance characteristics of common building materials. There are several materials which are commonly used in the construction of buildings. Fire resistance characteristics of these materials are discussed below. Stone. It is a bad conductor of heat. Sandstones with fire grains can resist fire moderately, granite disintegrates under fire, limestone crumbles easily, and most of the other stones disintegrate during the cooling period after they get heated by fire. Brick. Bricks can resist heat up to 1200 degrees Celsius. At the time of construction, if a good quality mortar is used to bind the bricks, fire resistance of the structure improves manifold. Timber. Any structure made of timber gets rapidly destroyed under the action of fire. Timber enhances the intensity of fire. Use of heavy sections of timber in buildings is not desirable. To make timber more fire resistant, the surface of timber is coated with chemicals such as ammonium phosphate and sulfate, boric acid, and borax. Sometimes fire-resistant paint is applied to the timber surface used in the building to improve the resistance. Steel. It is a good conductor of heat. Steel bars lose their tensile strength and begin to yield at the temperature of around 600 degrees Celsius. They completely melt at 1400 degrees Celsius. Steel columns become unsafe under a prolonged action of fire. Under a constant action of fire, steel reinforcement weakens the reinforced concrete structures. Hence steel columns are usually protected with brickworks or by encasing them in concrete. Reinforcement in concrete is protected by concrete cover, whereas steel grills and beams are applied with fire-resistant paints. Concrete. Concrete has a very good fire resistance. The actual behavior of concrete in an event of fire depends upon the quality of cement and aggregates used during construction. In the case of reinforced concrete and pressed rest concrete, the position of steel too influences the fire resistance ability. Larger the concrete cover, better is the fire resistance of the member. Concrete doesn't lose much of its strength up to the temperature of 250 degrees Celsius. The reduction in its strength starts when the temperature goes beyond 250 degrees Celsius. Normally, reinforced concrete structures can resist fire for about 1 hour at a temperature of 1000 degrees Celsius. Hence, cement concrete is ideally used as a fire-resistant material. Glass. It is a poor conductor of heat. It expands during heating, and when it cools down, cracks begin to generate in glass. Reinforced glass with steel wire is more resistant to fire, and during the cooling process, even if it breaks, fractured glasses stay in their original positions. Aluminum. It is great conductor of heat. It has got higher resistance to fire. Asbestos cement. It is a non-combustible material and possesses high fire resistance. Acoustics and sound insulations. The recommendation on acoustics and sound insulations given in Part 8 Building Services for Acoustics, Sound Insulations, and Noise Control of the Code shall be applicable. According to classic acoustics theory, there are 5 requirements which, when met, result in good acoustics. An appropriate reverberation time. Uniform sound distribution. An appropriate sound level. An appropriately low background noise. No echo or flutter echo. Factors to be followed for noise control in residential building. Room arrangement. Use of solid walls. Planning for single-story houses. Proper arrangement of balconies. Having courtyards. Construction of windows for acoustic control in buildings. Windows can be closed. Window size can be reduced. Glass thickness can be increased. Construction of walls for noise control in buildings. Wall mass and the thickness are increased. Use of cavity partition in buildings for noise control. Increase airspace width of walls. Increasing the stud spacing. Usage of studs in a staggered manner. Sound absorbing blankets used in the airspace. The cracks and edges are sealed. Thank you.